The term angles in 334.15c of the National Electrical Code, NEC, refers to the angles formed between the cable and the supporting surface. Specifically, it applies to the angles formed between the cable and the face of the studs. Installing a 4/0 SER cable on the face of studs in a straight line across the studs is not code compliant according to 334.15c of the NEC. This is because the cable is not secured at angles not exceeding 30 degrees from the horizontal as required by the code. To comply with 334.15c, a 4/0 SER cable must be installed in one of the following ways. Firstly, secured at intervals not exceeding 4.5 feet or 1.37 meters along each stud using staples, straps, or hannahs that hold the cable in place at angles not exceeding 30 degrees from the horizontal. Secondly, stapled or strapped to a running board lumper that is installed perpendicular to the studs at intervals not exceeding 6 feet or 1.83 meters, and the cable is secured to the running board at angles not exceeding 30 degrees from the horizontal. The requirement to secure cables at angles not exceeding 30 degrees from the horizontal helps to prevent the cables from sagging and creating potential electrical hazards. By following the proper installation methods, you can ensure that the electrical system is safe and compliant with the NEC. Let's delve deeper into the specifics of NEC section 334.15c concerning the securing and supporting of type NM, type NMC, and type NMS cables. This section outlines critical requirements to ensure safe and compliant electrical installations. The primary focus is on how these cables must be supported and secured to building structures. Understanding these requirements is essential for electricians and anyone involved in electrical work to prevent potential hazards and code violations. The core principle of 334.15c is that cables must be secured in a manner that prevents damage and maintains the integrity of the wiring system. This involves using appropriate securing methods and adhering to specific spacing requirements. When cables are run parallel to framing members such as studs, joists, or rafters, they must be secured within specific intervals to prevent sagging or displacement. The code mandates that these cables should be secured every 4.5 feet or 1.37 meters. This means that every 4.5 feet along the cable's run, it needs to be fastened to the framing member using staples, cable ties, straps, or similar devices designed for this purpose. These securing devices must be listed and identified for use with the specific type of cable being installed. Securing the cable at these intervals ensures that the cable remains properly supported and doesn't drip, which could lead to physical damage or strain on the connections. When cables are run across framing members, there are additional requirements to ensure proper support and protection. The NEC specifies that cables must be protected where they pass through or over framing members. There are several acceptable methods for achieving this. One common approach is to use a running board. A running board is a piece of wood, typically a 1-inch thick board, that is attached to the framing members perpendicular to the cable run. The cable is then secured to the running board at intervals not exceeding 6 feet or 1.83 meters. This method provides continuous support for the cable and prevents it from contacting the framing members directly. Another method is to bore holes through the framing members and run the cable through these holes. When using this approach, the holes must be drilled in the center of the framing member to maintain its structural integrity. Additionally, the holes must be smooth and free of sharp edges that could damage the cable insulation. If the holes are not bored in the center of the framing member, or if the edges are rough, the cable must be protected by bushings or grommets installed in the holes. These bushings or grommets provide a smooth, insulated surface that prevents abrasion of the cable. The NEC also addresses situations where cables are installed in accessible attics or crawl spaces. In these areas, cables that are run at angles to joists must be protected by guard strips. Guard strips are typically made of wood or metal and are installed alongside the cable to prevent physical damage. The guard strip should be at least as tall as the cable and should extend beyond the cable on both sides. This provides a barrier that protects the cable from being stepped on or damaged by stored items. When cables are run parallel to the joists in accessible attics or crawl spaces, they must be installed in a manner that protects them from physical damage. This can be achieved by running the cable along the top of the joists or by installing running boards as described earlier. The key is to ensure that the cable is not exposed to potential damage from foot traffic or other activities in the attic or crawl space. In unfinished basements, cables must be protected when run along the surface of walls or ceilings. The NEC requires that these cables be installed on running boards or be protected by conduit or tubing. This provides a physical barrier that prevents the cables from being damaged by contact with the concrete or other surfaces. It also protects the cables from moisture and other environmental factors that can degrade the insulation. It's important to note that the specific requirements for securing and supporting cables can vary depending on the application and the type of building construction. Always consult the latest edition of the NEC and any local amendments to ensure compliance with all applicable codes and regulations. Using the correct securing methods and adhering to the specified spacing requirements is crucial for ensuring the safety and reliability of electrical installations. Improperly secured cables can be subject to physical damage, which can lead to short circuits, ground faults, and even fires. Moreover, code violations can result in fines and other penalties. Therefore, it's essential for electricians and anyone involved in electrical work to have a thorough understanding of NEC section 334.15c and to follow these requirements meticulously. In addition to the physical securing of cables, it's also important to consider the overall management of cables within an electrical system. This includes proper labeling, routing, and separation of cables. Cables should be clearly labeled to indicate their function and voltage. This makes it easier to identify and troubleshoot circuits in the future. Cables should also be routed in a neat and organized manner, avoiding sharp bends or twists that could damage the insulation. Additionally, cables should be separated from other types of wiring, such as communications cables or low-voltage cables, to prevent interference or crosstalk. Proper cable management is an integral part of ensuring the long-term reliability and performance of an electrical system. By following the requirements of NEC section 334.15c and implementing good cable management practices, you can create electrical installations that are safe, compliant, and reliable. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. Now, let's elaborate further on the practical application of securing cables at angles not exceeding 30 degrees from the horizontal, as stipulated in NEC 334.15c. This requirement is often misunderstood, but it's crucial for maintaining the integrity and safety of the cable installation. The purpose of limiting the angle to 30 degrees is to prevent the cable from being subjected to undue stress or strain. When a cable is installed in a straight line across studs without any support between them, gravity will cause the cable to sag. This sagging can place excessive tension on the cable, particularly at the points where it's secured to the studs. Over time, this tension can damage the cable insulation, leading to potential electrical hazards such as short circuits or ground faults. By securing the cable at angles not exceeding 30 degrees, you distribute the weight of the cable more evenly and minimize the amount of tension on any single point. This is typically achieved by using appropriately sized staples, straps, or hangers that are designed to support the cable without constricting it. The securing devices should be installed in such a way that they hold the cable firmly in place, but without causing any damage to the cable insulation. In practice, this means that you might need to install multiple securing devices along the cable's run to maintain the desired angle. For example, if you're running a cable across studs that are spaced 16 inches apart, you might need to install a securing device in the middle of the span to prevent the cable from sagging excessively. The exact number of securing devices required will depend on the size and type of cable, as well as the distance between the studs. Another important consideration is the type of material used for the securing devices. The NEC requires that securing devices be listed and identified for use with the specific type of cable being installed. This means that you should only use staples, straps, or hangers that are specifically designed for use with Type NM, Type NMC, or Type NMS cables. Using the wrong type of securing device can damage the cable insulation or cause the cable to be improperly supported. In addition to using the correct securing devices, it's also important to install them properly. Staples should be driven straight into the framing member without damaging the cable insulation. Straps should be tightened securely, but not so tight that they constrict the cable. Hangers should be installed in accordance with the manufacturer's instructions, ensuring that they provide adequate support for the cable. When installing cables in areas where they are exposed to physical damage, such as unfinished basements or crawl spaces, it's important to provide additional protection. This can be achieved by installing running boards or by enclosing the cable in conduit or tubing. Running boards provide a continuous support surface for the cable, protecting it from being stepped on or damaged by stored items. Conduit or tubing provides a more robust level of protection, shielding the cable from impacts and abrasion. In summary, securing cables at angles not exceeding 30 degrees from the horizontal is a critical requirement of NEC 334.15. This requirement is designed to prevent the cable from being subjected to undue stress or strain, which can lead to damage and potential electrical hazards. By using the correct securing devices, installing them properly, and providing additional protection in areas where the cable is exposed to physical damage, you can ensure that your electrical installation is safe and compliant with the NEC. Furthermore, let's consider the scenario where running boards are used to support cables. The NEC allows for the use of running boards as an alternative method of supporting cables, provided that certain conditions are met. A running board is typically a piece of lumber, such as a 1-inch by 4-inch or 1-inch by 6-inch board, that is installed perpendicular to the framing members. The cable is then secured to the running board at intervals not exceeding 6 feet, or 1.83 meters. This method provides continuous support for the cable and prevents it from contacting the framing members directly. When using running boards, it's important to ensure that they are securely fastened to the framing members. This can be achieved by using screws or nails that are long enough to penetrate the framing members by at least 1 inch. The running boards should be installed in a straight and level manner, ensuring that they provide a uniform support surface for the cable. The cable should be secured to the running board using staples, straps, or hangers that are listed and identified for use with the specific type of cable being installed. The securing devices should be installed in such a way that they hold the cable firmly in place, but without causing any damage to the cable insulation. When running cables along running boards, it's important to maintain adequate spacing between the cables. The NEC specifies that cables should be separated by at least 1 cable diameter to prevent overheating. This spacing allows for adequate air circulation around the cables, preventing them from becoming excessively hot. In addition to spacing, it's also important to consider the ampacity of the cables. The ampacity of a cable is the maximum amount of current that it can safely carry. The ampacity of a cable is determined by its size, insulation type, and installation method. The NEC provides tables that list the ampacities of various types of cables under different installation conditions. When installing cables on running boards, it's important to ensure that the ampacity of the cables is sufficient to handle the load that they will be carrying. If the ampacity of the cables is not sufficient, they could overheat and potentially cause a fire. In some cases, it may be necessary to increase the size of the cables to ensure that they have adequate ampacity. Another important consideration when using running boards is the presence of any sharp edges or protrusions that could damage the cable insulation. The running board should be inspected for any such hazards, and any sharp edges or protrusions should be removed or covered. This will prevent the cable insulation from being damaged by abrasion. In addition to running boards, conduit or tubing can also be used to provide physical protection for cables. Conduit is a rigid metal or plastic tube that is used to enclose and protect electrical wiring. Tubing is a flexible metal or plastic tube that is used for the same purpose. Conduit and tubing provide a high level of protection for cables, shielding them from impacts, abrasion, and moisture. When using conduit or tubing, it's important to ensure that it is properly grounded. Grounding is the process of connecting the conduit or tubing to a grounding electrode, such as a ground rod or a metal water pipe. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. The NEC specifies the requirements for grounding conduit and tubing, including the size and type of grounding conductors that must be used. In summary, running boards, conduit, and tubing are all acceptable methods of providing physical protection for cables. The choice of which method to use will depend on the specific application and the level of protection required. When using any of these methods, it's important to follow the requirements of the NEC to ensure that the electrical installation is safe and compliant. And considering accessible attics and crawl spaces, the NEC has specific requirements for the installation of cables in these areas to protect them from physical damage. Accessible attics and crawl spaces are areas that are subject to foot traffic and storage, which can potentially damage cables that are not properly protected. When running cables at angles to joists in accessible attics or crawl spaces, they must be protected by guard strips. Guard strips are typically made of wood or metal and are installed alongside the cable to prevent physical damage. The guard strip should be at least as tall as the cable and should extend beyond the cable on both sides. This provides a barrier that protects the cable from being stepped on or damaged by stored items. When cables are run parallel to the joists in accessible attics or crawl spaces, they must be installed in a manner that protects them from physical damage. This can be achieved by running the cable along the top of the joist or by installing running boards as described earlier. The key is to ensure that the cable is not exposed to potential damage from foot traffic or other activities in the attic or crawl space. In addition to guard strips and running boards, conduit or tubing can also be used to protect cables in accessible attics and crawl spaces. Conduit and tubing provide a high level of protection for cables, shielding them from impacts, abrasion, and moisture. When using conduit or tubing, it's important to ensure that it is properly supported. The NEC specifies the requirements for supporting conduit and tubing, including the maximum spacing between supports. The support should be installed in such a way that they hold the conduit or tubing firmly in place, but without causing any damage. In addition to physical protection, it's also important to consider the environmental conditions in accessible attics and crawl spaces. These areas can be subject to extreme temperatures and humidity, which can degrade the cable insulation over time. To mitigate this risk, it's important to use cables that are rated for the specific environmental conditions in the attic or crawl space. The NEC specifies the types of cables that are suitable for use in different environmental conditions. In addition to using the correct type of cable, it's also important to ensure that the cable is properly sealed to prevent moisture from entering the cable insulation. This can be achieved by using sealing fittings or by wrapping the cable with waterproof tape. In summary, the installation of cables in accessible attics and crawl spaces requires special attention to protect them from physical damage and environmental factors. Guard strips, running boards, conduit, and tubing are all acceptable methods of providing physical protection for cables. Using cables that are rated for the specific environmental conditions and sealing them properly can help to prevent degradation of the cable insulation.